Hello viewers, in this video I would like to discuss question number 2B of operations research of 2018 CS main exam paper 2 mathematics, and question is solve the following linear programming problem by Big M method. So Big M method, and show that the problem has infinite optimal solutions. Also find the value of the objective function. So problem is minimize z is equal to 3x1 plus 5x2 subject to x1 plus 2x2 is greater than equal to 8, 3x1 plus 2x2 is greater than equal to 12, 5x1 plus 6x2 is less than equal to 60, x1 x2 are greater than equal to 0. This is a question of section A and it is having marks 20. So this question is of 20 marks. So for solution, what we do, we first introduce slack variables, surplus variables, artificial variables, and write down the given problem. The standard form of the problem is minimization z is equal to 3x1 plus 5x2 plus 0s1 plus 0s2 plus 0s3 plus ma1 plus ma2. I will come back to this statement later. Subject to x1 plus 2x2 minus s1 plus a1 is equal to 8. Our first constraint is greater than equal to, so left hand side is having some surplus, and because we want to apply simplex method, we have to add artificial variable also when constraint is greater than equal to. So x1 plus 2x2 minus s1 is the surplus variable and a1 is the artificial variable is equal to 8. Now this constraint is equal to sign. Second constraint is also similar to first one, so we write 3x1 plus 2x2 minus s2, this is surplus variable, plus a2, this is the artificial variable, is equal to 12. Third constraint is less than equal to type. It means we have to add slack variable, so 5x1 plus 6x2 plus s3, this is the slack variable, is equal to 60, and all the variables x1 x2 s1 s2 s3 a1 a2 are greater than equal to 0. So we go back to the objective function, that is minimization z is equal to 3x1 plus 5x2 plus 0 s1, because we have taken it as surplus variable, plus 0 s2, this is also surplus, plus 0 s3, this is slack variable, plus ma1 plus ma2. M is a number which is very large and a1 a2 are artificial variables. Now we may write the objective function as, by taking all the terms on the left hand side and right hand side making as 0. So z minus 3x1 minus 5x2 minus 0s1 minus 0s2 minus 0s3 minus ma1 minus ma2 is equal to 0. So from here we formulate the table or write down the table, and we see that in the constraints a1 a2 s3 are the variables, so we take them as basic variables a1 a2 a3 by putting x1 x2 s1 s2 are the non-basic variables, we take them as 0, and we get the value of a1 as 8, a2 is 12 and s3 is 60, and z row is the coefficients of z row are 1, minus 3, minus 5, so minus 5, 0, coefficient of s2 is 0, s3 is 0, a1 is minus m, a2 is minus m, and solution is 0. So here we see that there is some inconsistency in the table. When we compare this table with the all slack variables in the starting table, their slack variables have coefficients as 0, but here we have coefficients and as minus m and minus m, and this is creating some inconsistency in the table. So before doing the simplex calculations, we do some corrections in the table. So we see that what is the value of z when we take the x1, x2, s1, s2 variables as non-basic variables, and a1, a2, s3 are basic variables, and non-basic variables have values 0 and basic variables have values 8, 12 and 60 respectively. When we substitute values of a1 and a2 in objective function, that is z, we get the value of z as 8m plus 12m and get 20m. In the previous table we have written value as 0 instead of 20m, so there is an inconsistency and we have to eliminate this. So we use this formula, new z row is equal to old z row plus m into a1 row plus m into a2 row. So when we write this formula and apply, we get new z row, and we see here that coefficients of a1 and a2 are now 0. Earlier they were minus m and minus m, and due to that this problem has been created here. So now we see that solution is 20m, which is compatible with the values of a1, a2 and s3, and we got the solution here 20m. Now we can apply simplex method calculations here, and we see that this is a minimization problem, so we have to check which one is the most positive element in z row. In z row we see that this 4m minus 3 is the most positive element because m is a large number, so this becomes our entering variable, that is x1 is now entering variable, and this column becomes our pivot column. And now we find out ratio with the help of solution elements. So we divide each element of solution by the corresponding element of the pivot. So we get 8 upon 1 is 8, 12 upon 3 is 4 and 60 upon 5 is 12. So we see minimum value is 4, and corresponding to this the leaving variable is a2. Now a2 is leaving variable and x1 is entering variable, and the intersecting element of entering variable column and leaving variable row is 3, that becomes our pivot element. And now we divide this row a2 by this element, that is 3, so our row becomes 0, 1, 2 by 3, 0, minus 1 by 3, 0, 0, 1 by 3 and 4. So this new row and this a2 we replace by x1. So here in the next table this will become x1 and the elements will be 0, 1, 2 by 3, 0, minus 1 by 3, 0, 0, 1 by 3 and 4. With the help of this row we will change our a1 row, z row and s3 row. And how will we do those calculations? Let's see. Each element, corresponding element we will take and we will do the calculations. So we see that a2 row is a2 row by 3, which I have already told you, and a2 we replace by x1. a1 row is a1 row minus 1 into new a2 row. 1 is the element which is in the pivot column and corresponding to a1. So a1 row, the earlier, which is in the previous table, and 1 is the element which is in the pivot column corresponding to a1, and new a2 row element is whatever we got after dividing by 3. So for each element we will do this calculation. S3 row is S3 row minus 5 new a2 row. So we got new S3 row, which is S3 row minus 5 new a2 row. Now new z row is z row minus 3 plus 4m. Minus 3 plus 4m is the element in the pivot column corresponding to z into new a2 row. Now what happens that we see that let's see two elements which were minus m and minus m in the previous table corresponding to s1, s2 in z row. So what we do here, minus m, this is the Z row element minus 3 plus 4m, and new A2 row element corresponding to this is 0. So this becomes our minus m. And in S2 earlier element was minus m, so minus m minus 3 plus 4m into minus 1 by 3. When we do this calculation we get m by 3 minus 1. So for each element we will be doing these calculations and we get all the elements. Again we check which one is the most positive. If positive element is there in Z row, we see yes, there are positive values. This one is positive, that is 4m upon 3 minus 3. Then m by 3 minus 1 is positive, and rest of them either are 0 or negative. So 4m upon 3 minus 3, this is most positive. This becomes our entering variable. X2 is entering variable. We find out with the help of this pivot column and solution column. We find out ratio is minimum is 3, and corresponding to 3 is a1 is the variable which will be the leaving variable. So this element which is at intersection of entering variable and leaving variable row, we get pivot element. We divide this whole row with the element 4 upon 3. So we divide this whole row by this and get new row. So a1 row divided by 4 by 3, and we replace a1 by x2. So next table will give us these values. And then new x1 row, which is this one, new s3 row and new z row will be calculated with the help of these formulas. X1 row, which is this row right now here, minus 2 by 3 is this element here, 2 by 3 into new a1 row. New a1 row here becomes 1. So for this element, so when we do these calculations, we see in the pivot column the this pivot element row element will be 1, and rest of the elements in the column, in this column, in pivot column, will be 0. And new s3 row will be s3 row minus 8 by 3 into new a1 row. New z row is equal to z row minus 4m upon 3 minus 3. So this is the element in this pivot column corresponding to z element, that is z row, into new a1 row. So when we do these calculations, we get the following table. So in this table we see that in Z row the elements are either 0x1 is 0, x2 0, s3 0, or the elements are negative, s1, s2, a1, a2, all of them are negative. So we have reached to our optimal solution, and we can see that here value of x2 is 3 and value of x1 is 2 and value of s3 is 32 and solution is 21, that is value of objective function. So once we got all negative values in Z row or 0, not a single value is positive, we have reached to our optimal solution and we got these values. Here we see that x1 is 0, x2 is 0 and s3 is 0. So if we, these three are already in the solution, x1, x2, x3, these three are already in the solution. So if we make them to enter again in the solution, there won't be any effect. So there is a unique solution and we don't have infinite many solutions here. This we can confirm with the help of graph also, which I have done, and I have seen there is only this unique solution, which is minimum value of z is 21, x1 is 2 and x So optimal assignment and cost is O1 gets M3 and cost is 18, O2 gets M1, cost is 17, O3 gets M4, cost is 17, O4 gets M5, cost is 24, O5 gets M2, cost is 16, and total cost is 92. Solution satisfies the given conditions that O2 is not on M5 and O3 is not on M3. Thank you. Hello viewers, in this video I would like to discuss question number 1E of Operations Research of paper CS Main 2016 Mathematics paper 2. This question is from section A and this question is based on graphical method and it is of 10 marks. So question says that find the maximum value of 5x plus 2y with constraints x plus 2y is greater than equal to 1, 2x plus y is less than equal to 1, x is greater than equal to 0 and y is greater than equal to 0 by graphical method. So first we write down the problem in standard format. Let's say the objective function is z, so maximize z is equal to 5x plus 2y and subject to the constraints x plus 2y is greater than equal to 1, first constraint, 2x plus y is less than equal to 1, second constraint, x and y are greater than equal to 0. To find the value of objective function which is maximum, we need to find out points on the x-axis and y-axis as well as intersecting points of these two constraints. So from first constraint we say x is equal to 0, we get y value as 0.5. When x is equal to 1, we get y value as 0. For second constraint, when we take x 0, we get y value 1, and when we take x value as 0.5, or other way we can say that when we take y value as 0, we get x value 0.5. Now we got these 2 points. So after solving these two equations, we get value of x as 1 upon 3 and value of y as 1 upon 3. Now we plot these points, and from first constraint we have that 0.5, this and 1 0, and this is greater than equal to, so we will have this area. And second constraint gives us these points 0 1 and 0.50, so we will have this area. But when we have intersection of these 2 points, so we get the feasible region, which have been drawn here with this blue lines. So we got this feasible area. This area is feasible area in this triangle. So it has been shown with the blue lines also, the feasible area. So now we have endpoints of this 0, 1, 0 and 0.5, 1 upon 3 and 1 upon 3. This point is 1 upon 3 and 1 upon 3. So we got corner points that is 0 and 0.5, 0 and 1 and 1 upon 3 and 1 upon 3. So when we calculate value of z, that is objective function, on these points we get value of z as 1 at 0 and 0.5, value of z at 0 and 1 is 2, and at 1.3, 1.3 it is 2.